Hey there, it's Monday morning, and normally I do these on Sunday morning, but I didn't because I was busy doing some other things. And thought I would come out here this morning and make a bit of a follow-up video to yesterday's video on my main channel on part 3 of this CNC build. In that video, I actually put in the linear bearings for the y-axis and the lead screws and motors. I also extended the sides up 3 inches to deepen the bed. Okay, that was my plan from the beginning. And I should point out that people watch these videos and they see this stuff going on, and they don't seem to realize that, okay, I don't know about anybody else, but before I get started on anything like this, I do a lot of planning. Okay, I didn't used to. Back in the old days, I used to jump right in. I would do very little planning. I would, sketch something out on paper, get some ideas, and before I could talk myself out of those ideas, I ran out to the shop or my garage or wherever to start working on it. Right? Dive in. But that's not today. I spent a lot of time before I even, think about buying material or coming out or doing anything, planning the project. And this is no exception. Actually, this is the rule, the new rule, okay? The new standard for that kind of thing. And I'm going to show some of the plan just to point out a couple of things. Now, I'm getting a lot of feedback, you could say, on how I built the y-axis on this and made those extensions. And then, I put the I put the linear bearings on the wood. Why didn't you put it on the concrete, John? Well, a couple of reasons why I didn't put it on the concrete. First of all, I didn't design it that way. Okay, I designed it from the get-go, put those linear bearings on those extensions. Okay, 2 big reasons for that. When I started working on the design, one of the deficits, or one of the issues with the one this replaces, the one I built last year, okay, and used many times, was the height of the gantry sides. Now, in that instance, they were made from aluminum, from the Stepcraft machine. They're the actual gantry sides from the Stepcraft machine. So it's aluminum that's almost a 1/2 inch thick, okay? And even that had a little bit of deflection side to side. All right, and it had nothing to do with my very well machined bearings in that machine, where I just cut a groove in aluminum blocks that fit over the hardened steel linear guide rails, because I didn't have any bearing blocks for that. If you watch that build, you'll know what I'm talking about. That was another little controversial thing, although very few people watched that video, so I didn't get a lot of feedback on that. Anyway, so there's a little bit of side-to-side deflection in that gantry assembly because of the height of the sides of the gantry. So I said, one of the things that I want to do in this new machine is to reduce the height of the gantry sides. That means I could either start with a very tall concrete base, the sides would go up another 3 inches with the concrete, or I said, I can build a structure on top of that bolts down securely to the base, to the top of those rails, and facilitates the linear bearings and the lead screws, space in there for those 2 things. Because if you extend the sides up with concrete, you don't have any space for that. You have to put the bearing, you have to put the linear bearing on top of the concrete, and then where you're going to put the ball screw, the lead screw. Where's it going to go? Okay? If your gantry side comes down, it has to go outboard. And it adds to the width, and it makes it more complex to my way of thinking as I was designing it. So I made that compromise, okay? I added a very slightly weaker assembly to the top of the Y rails to fit all that mechanism inside. The lead screw at the bottom and the linear bearing at the top. And the comments I'm getting from people who obviously don't know how strong that connection is to the base, first of all, and grossly underestimate the strength of wood in general. They think that wood is like a sponge. Okay, it's like this. Right? This was sanding sponge, just like that. They got no idea. Okay, wood is softer than metal, obviously, yes. And stiffer. Metal is always going to be stiffer lead. But you take that piece of 3/4 inch Baltic birch plywood, I use good plywood for it, and the height of it is limited, 3 inches, not tall at all. And you put an aluminum plate on the bottom that's screwed into it with many screws, and then you screw that down to the base. You got a very solid connection there. And then you cap it with another plate of aluminum to increase stiffness, but that's not what I have that there for. I have it there to cover the stuff that's underneath. Then, then you take the linear bearing, which is a piece of hardened steel. This is the end cut off one, or this is, anyway, the end cut off one. This is very strong steel, okay? And it's 50 millimeters, that's 9/16 square profile, you could say. So this alone being bolted on or screwed onto that plywood increases the stiffness of it quite a lot as well. So I'm counting on all of that structure to make up the strength of that assembly. I'm looking at the whole picture. And that's not all, and that's where the drawing comes in. I'll briefly show it here so you can see what I'm talking about. So with that space cut down to a bare minimum, there's very little chance that it will move side to side. It also reduces the effective height of the gantry sides, taking that out of the equation. As in, it doesn't need to be made from, 1/2 inch thick aluminum or steel. The plywood that I used once again for the gantry, because you'll see that coming up, more plywood, more spongy plywood. Where's that piece of plywood? Here it is right here. More of the spongy plywood will be used for the gantry. And okay, with that shortened span that the gantry side has, also the gantry links both sides. Okay, you got the y-axis here, y-axis there. What bridges between them and is solidly connected through those linear bearings is the gantry. So if one side is trying to move, it's pulling the other side with it. And that doubles the stiffness right there, because you're not just relying on one upright on one side, it's actually connected to the upright on the other side as well. Anyway, that's all I have to say about that. I'm under no illusions that I'm going to be reaching the people that need to hear that, because first of all, they don't want to hear it. They want to be right. They think they're right. They sit around watching YouTube videos. That makes them an expert on the topic. You can't fight that, okay? The only way to fight that is for them to actually get up off their bums and make something and learn by making, experience. Especially working with wood, I can't say quickly, but you eventually come to learn just how strong it is and what its limitations are, okay? And I have not, by any stretch of the imagination, exceeded the limitations of wood in this build. Now, I know some of you are probably sick of the CNC stuff, even before I got started. And it's going to continue on. The build is way ahead of the videos that I'm posting on YouTube, and that'll continue. I've probably got 3 more videos before I catch up to the current progress, and it's not quite done yet, but it's close. So that'll continue on, and then after that, I want to get started on a purely woodworking project, but one that may use the CNC for certain operations. I'm not sure yet. It's a very complex toolbox. Now, I made a toolbox a few years ago, and that started out as an idea I had for something a lot more complex, but in the end, I compromised and made it more simple to try to get it done quicker. And I did. I got it done quicker. I wasn't entirely happy with it. I wasn't entirely disappointed with the results, but it didn't meet what I set out to do to begin with. So I want to try again, as in build a new toolbox that that actually fits the description that I had going into that one. Okay? And that'll be coming up after the CNC build, as far as I know. I actually made a post on Patreon showing the box design, and I posted the SketchUp file that I drew as a preliminary design start for it. So if you're interested in seeing the details on that build as it's happening, and also, you know, further progress on the CNC behind the scenes, sign up to my Patreon page. The link is in the description.
You get 2 sheets every Saturday. You put the clean sheet in the top sheet in the bottom sheet you turn in the laundry board. Any man turns in the wrong sheet spends the night in the box. Which? No one will sit in the bunks with dirty pants on. Any man with dirty pants on sitting on the bunk spends the night in the box. Any man don't bring back his empty pop bottle spends the night in the box. Any man loud talking spends the night